Hi there. Now we're going to do some operations with logs or some simplifying, and there's a set of rules to work through. So I'm just going to go through it similar to your textbook. And first of all, we're going to apply the log rule for products. So if you have two logs that you add together, you can simply multiply the two numbers, provided the base or the little subscript number next to the log is the same. You can then just take the x and y and multiply together. So for part A, we have this one here. We leave the base alone and we just times 3 by 4. So that one's the same as log base 5 of 12. Next one, part B, we do have the same bases, so we can do the product of these ones, 15 times 3, which is log base 2, 45. Okay, the next rule is when we are subtracting two logs and they have the same base. So what we can do is we can put it into a quotient. So we can actually go both ways, but what we're doing here is we're simplifying. So that means we're going to do it as one log. So we've got two logs here that are subtractions, and we're going to change it into a division. So log, keep the base the same, and it becomes 35 over 7. Log 2, which is 5. Now you don't have to put the brackets around the 5, but sometimes it just makes it really clear, so it's okay to do that too. Another example here, log base 3, and we have 24 divided by 8, which is 3. So log 3, 3. Now sometimes you can have a little look at these and go a bit further. So if we actually look at this and think, what does it mean? What about if we think about what it meant in the index form? So remember, the little 3 is the base. This one here is the answer. So what we can actually say is, hey, this actually equals base 3 to the power of something equals the answer 3, the y. Okay, so that's the y there. That's the base there. And the answer or the power is this guy here. So 3 to the power of what made 3? Oh, that's actually 1. So this whole thing equals 1. So although we've simplified, we've actually also managed to evaluate. Let's go back to A and see if we can do the same thing. So the 2 was the base. The 5 was the answer when we changed the log form into index form. And we don't know what this equals. And so the answer that it equals is actually the power. So that doesn't actually really help because it's not an easy one to do. It's not clean numbers for us, but just this one happened to be. Okay, moving along to the third rule, it's the power rule. So what this rule does is we have log base number to the power of something. And what we do is we take that little power that's on the base and we take it out in front of the log as a multiplier. Okay, so you might have to learn this one. This one's really, really useful. So it's useful because it helps us solve powers, and it's actually the focus of a future lesson, very upcoming. So let's just see how that works. So if we have something that's this way and we're simplifying it, we take the 5 and we put it out in front. So it's 5 log 2 to the power of 3. I don't know that that's simpler, but I guess we're just applying that rule. I would think that if I took this guy here, actually let's run with it. Let's go 5 times log 2 to the 3, and let's just transform this into a whole number. So we know that log 2 to the 3, 2 to the power of something equals 3. That's not really going to work for us. So I'll just leave it at that. I think it could have been simpler not to go down that road, but to do this for our simplification. Log 2, 3 to the 5. And now what I'm going to do is I'm going to apply that index to 3 to the 5. And that gives us log base 2 to the 243. That's actually simpler. So we haven't actually used this law yet. What I've actually only done to here is I have basically just applied the power. So there was no point bringing it out in front. I was better off just to power up 3 to the power of 5. And I actually think this looks a lot simpler. So we'll just leave it at that. It's a little controversial, but let's use our second example to see if applying this rule is useful for us here. So we take the minus 5 and we multiply it by the rest of what was already there, 2 log 2. Now what you need to do here is you need to stare at log 2, 2. And if you think about it in index form, 2 to the power of what equals 2? Please tell me it's 1, okay? So that guy there, log 2, 2, is equal to 1. So what we have here is negative 5 times 1, which equals 5. So this entire thing just equals 5. Okay. So here's a summary of the log rules that we have applied. Basically, the first 3 here are principles or properties of logs that line up with the power rule. So in this case here, let's start with the first one. This is just what a log is, and this is how we change it to an index form. So remembering the little number, the subscript, which is the text that sits underneath, past the log is your base, what the log thing equals is your power, and the answer to the index expression is the y. So it's a little muddled up, but it's really important to be able to go back and forth from these two. The second one here is log a1 is 0, and that's because if we flip it over to power form, the power of anything raised by 0 will give you the answer 1. So here when we see the 1, we have to realize we don't care what the a is, it's just the whole thing's going to be 0. Next one here is just remembering log a. So any two values the same here on this side is going to be 1, because when we take a and we expand it to the power 1, we get the same thing, a. All right, so those are just our logic things that we need to remember in the top 3. The next ones down was the fact that if you are adding 2 logs, you can multiply those 2 numbers together and apply the product rule, and similar to the index powers. And the next one was if you are subtracting 2 logs with the same base, you simply can divide those numbers together to simplify it. And lastly, we have this thing here where if you have a log and the number, the answer is raised to the power of something, you can multiply it in front of the log. This one here comes into its own in a couple of lessons, and it is quite an important rule for helping us find answers to problems. So next we're just